Hi, I'm Em with Sceviour Systems, and today I'm going to introduce you to the RoboRescue emergency response bot. I'm so excited to be sharing this robot prototype with you today. We are so excited to get this on the market. Hopefully you will like our design and our prototype, and you will consider it for your response robot. I'll get right into the presentation. So our robot features 4 motors and wheels. Its intended purpose is to move around environments, sense disasters, sense weather, and scan for survivors. So having motors was very important for us. Of course, the intended function is to act as an emergency response bot, as you know. So we will be using this in the event of extreme weather or natural disasters. And we will be able to deploy this wherever humans are not able to get, or it has been deemed unsafe to for human contact there. So, as I said, the motors were a key function in our robot. It's very important that our robot can move through certain environments, and we're so excited that our robot is able to be in motion and make its way around. To assist in our rescue, we have a number of onboard sensors and output functions that will help the missions at hand. Operators can use these functions from their graphical user interface, which is more or less an application, and that will be used remotely on their computers in their office. So the great thing about this is the operator can be in their office or on the ground, and the response robot can do their job at the site at hand. So in order to go through the functions, I'm going to go through these in detail, but just as an overview, a number of features that we have on the robot that will help with its intended function is a camera, of course, to go through certain environments, scan and capture photos of disasters, any wreckage, and pick up on any survivors. We also have a number of input functions that help with this, especially with sensing environmental conditions. We have a temperature sensor, a vibration sensor that will be able to sense tremors in the environment. We have a light sensor, and we also have a motion sensor, which will help pick up survivors. For our output features, we also have a buzzer, which will beep usually if there's a certain circumstance, and we also have a warning that plays a very loud alarm sound when certain environmental factors are occurring. Our bot has headlights at the front of the robot, which will turn on automatically depending on the amount of light that is available in the atmosphere, as well as bots on the robot that indicate what sensing it's doing. For example, the red sensor corresponds to temperature, I believe, and of course we will not be able to see that on the bot, but our graphical user interface will report in real time also. So without further ado, I'm going to go through the specific features of this robot with you. We have our fritzing schematic for our RoboRescue emergency response bot. We will go over these input and output functions and then go over our system of interconnectedness diagram to show you in detail what exactly these features do and why they serve a purpose on our robot. This is just to go over our wiring. Of course, we have our motors here and here. We have our light sensor, our speaker, our motion sensor, our vibration sensor, our buzzer here, 2 LEDs that act as headlights, a temperature sensor, and of course our Pi camera. These are all connected to this, which is our small breadboard that's connected to our Raspberry Pi. This here is called our Explorer Hat Pro, and it is the brains of our operation. Next, I will show you our system of interconnectedness diagram to go over the output and input functions of interconnectedness diagram, which is shortened SID on many of our documents. This will go over the system of our robot and how they're connected and what their functions are. So first we have the brains, which is our Explorer Hat Pro here, mounted on top of our Raspberry Pi. Of course, we have our motors and wheels for locomotion. We have 4 motors that are attached directly to the Explorer Hat Pro by motor 1 and motor 2 functions here. Of course, then we have our Pi camera, which will serve as a scan and capture function. This is mounted directly to our Raspberry Pi. Our output features are 2 LED headlights that are mounted at the front of our Raspberry Pi, which will help illuminate the environment around it. We have a buzzer as well as an alarm that act as output features for sound. Then last but not least, certainly we have our input and sensing functions. We have our vibration sensor here, our temperature sensor here, our motion sensor here, and our light sensor here. And these will assist in the scan feature of our bot, which is arguably the most important feature of our robot. For your specific operators, and they would each have their own unique password. I'm going to enter my password, and here is our for your specific operators, and they would each have their own unique password. So I'm going to enter my password, and here is our graphical user interface. I'll just go over this quickly. We have our end button here, which will exit the program. Motor controls on our operations. These are for our motors, motor stop, and then of course we have our directions. Our GUI features a light mode and a dark mode for using in the day versus the night. The dark mode will set the color scheme to like a grayscale with our emergency stop and end buttons easily seen. From there, we have our system functions, our headlights, our alarm, and our warning that plays. We have our camera operations. You can do a camera preview for scanning, and you can take a photo, which will stamp the time. On the right-hand side here, we have user information, your username, your shift data, which is the time what you clocked in, as well as a scan and print report function. The onboard light legend is for the lights at the back of the breadboard on top of our rescue robot. So they will not be able to be seen while it's in use if it's deployed and an operator is using it remotely, but it will be generated in the report in our compiler here. So we'll begin to show you our robot and its functionalities. Of course, our robot moves forward. It can reverse. We have left and right functions. As you can see in our compiler, every action that we're doing, our robot is going to update us in a report so we can see generally how far the robot went during the shift, and it can kind of track the location and the times of our specific events. I've shown you light mode and dark mode, but just to show again. Our ROBOrescue bot comes equipped with headlights here and here. To turn the lights on, we can lights on. It has a buzzer, which is just at the back here, this middle guy. Buzzer on. Buzzer off. We also have a warning that's used if the temperature goes over a certain degree Celsius. This is our warning. course, be used also on its own. So we'll go over the camera functions now. Camera preview will do a scan that will show you a screen scan of the environment. We're just going to take a photo, and I'll show a sample photo in the document. However, our camera is just mounted here, so right now we won't get a photo of real-world environment, so I will be putting a sample photo that was taken earlier on in our prototyping. So to take a photo, we click our button. Our report will generate when the camera took the photo, and it will timestamp it, so if any survivors were captured, we can capture a photo and record the time that it was exactly captured. In order to scan, we can press our scan button. This is going to read temperature, vibration, light, and motion. So our scan will complete all of those in order. As you can see, our report shows that there was no motion detected. There was no light detected, and it turned our headlights on. We can turn them off. And it is showing our temperature was outside of the normal level. That is why you heard the warning sound. No vibration was detected, so there were no tremors, and then our scan is complete. You can do a scan as many times as you'd like in a normal mission. It's probably intended to do them every few minutes or so, just so you can get an accurate reading, and especially when searching for survivors. So we'll show you here that we turn the headlights off. Alrighty, let's say our shift is ending. We can print our report, which will generate here, and then our app will automatically close. Our shift time will show up in this corner here, and then our end of report generates, and that is all.